Good morning and welcome to Physics Lab. For today's experiment, we will do experiment number 6, heat capacity of solids. In this experiment, we will see three types of solids, the copper, glass, and lead. So as I said, the objective or the main objective of this experiment is to find the heat capacity of these three types of metal, each one separately. So in order to complete this experiment, we are in need of different material. The materials that we will use, here we have a heating apparatus, we have a water container with a connected to a rubber tube, and the rubber tube will go to a double wall container. Here we have a double wall container, so we have the initial or the outer cylinder and an inner cylinder. In the inner cylinder we will put the metal that we are looking to find the heat capacity. So first we will start by the glass, for the glass shots. We put the glass shots inside the inner cylinder. So between the inner cylinder and the outer cylinder there's a air zone. So the steam coming from the heating apparatus and water, the steam coming from the water by the rubber tube will move between the two cylinders, and then the temperature of the steam will be delivered to the shots. And from the second side we have a rubber tube to a container, sends the steam by touching the outer cylinder, and the outer cylinder is cold, so it will be transferred to water. As well, we are in need to a dewar vessel. The dewar vessel has a cover with a mesh, and using the dewar vessel is similar to the use of a thermostat. So it will conserve the temperature and he will not let the temperature going to the atmosphere or the outer zone. So now to start the experiment we have to fill the container, the water container, by water. So we put water to the maximum. We have to make sure that the cover is well putted, and so the steam cannot have only one exit zone, which is the rubber tube. So now the water container and the cover are well done. We turn on the heating apparatus. Okay, and now we have to wait for 20 minutes. 20 minutes, in the 20 minutes, the water will the temperature of water in the container will increase to 100 degrees, and then the water will be transferred to steam. The steam will go by the rubber tube, and then the steam will be moving between the two cylinders. And then after 20 minutes, we can assume that the temperature of the shots is 100 degrees, the temperature which is the temperature of the steam. By waiting the water or the 20 minutes needed to complete the experiment, now we have several steps to complete using the dewar vessel. First of all, we have to measure the mass of dewar vessel, without the thermostat. So first we start by measuring the weight of or the mass of the dewar vessel, empty dewar vessel with the cover. So it is 322.8. So dewar vessel with cover, which is M0, 322.8. Now we remove the cover. There we set at 0, and we have to fill the dewar vessel with about 180 grams of water. So we don't need to be so accurate at 180 grams, but we need to record the exact mass of water, and which should be about 180 grams. Now we have 46 grams. $122. Okay. So the mass of water is 184.6 or 184.8. So by reading the experiment, we see that M2, small m2, is the mass of the water. So mass of the water is 184.8. So small m2, 184.8 gram. Now I have to measure again the mass of water with the cover and the dewar vessel. So dewar vessel was cover and water, it's 507.9. So M prime is 507.9, and at the end of the experiment we have to measure M double prime, which is the mass of dewar vessel with shots and water. M double prime, the mass of dewar vessel with water and shots. What we remain to do is to find the initial temperature of water. So I will put the thermostat on the cover of the dewar vessel, and we will wait for about 5 minutes, and then we will measure, or we will read the value of the temperature of water, the initial temperature of water. After 20 minutes, we have to open the double wall container and let the shots go into the dewar vessel. We close directly the cover of the dewar vessel in order to not have a heat transfer to the environment, and then we record the new temperature of water, and we will see how much is the temperature of the system, water plus shots and the dewar vessel has changed. By using the temperature of water, the variation of temperature of water, we can find the heat capacity of glass, and the heat capacity of glass will be found using the two equations. Q1, which is the heat quantity involved by the shot. So heat quantity delivered by the shots. Q1 is equal to M1 C1 times delta T, or T1 minus T final. In our case, T1 is 100 degree and T final is the new, or is the final temperature of the system. This Q1, this quantity involved by the shots, will be equal to the quantity absorbed by the system, which is Q2. Q2 is heat absorbed by the water and the Dewar vessel. And that's why we will see by the equation that we have M2, the mass of water, plus Mk, which is the equivalent mass of the Dewar vessel by water. So here we have Mk is 23 gram. Since the Dewar vessel, why we will use this Mk and this and 23 gram? In fact, this Dewar vessel will absorb heat. And in order to take into consideration this quantity of heat absorbed by the Dewar vessel, and as we can see, the Dewar vessel has an initial mass of 322.8 gram. This 322.8 gram is equivalent or will absorb heat equivalent to 23 gram of water. So that's why in order instead of using the 322.8 and the heat capacity of the Dewar vessel, we will use 23 gram because this 322 is equivalent to 23 gram of water, and that's why we add to the mass of water M2 plus Mk. So that's why we are using M2 plus Mk times C2. C2 is the heat capacity of water, times delta T or T1 minus T2. T1 or T final minus T2. T final is the final temperature of the system, and T2 is the initial temperature of water. So we need to wait for 7 minutes. So now we have to read the value of temperature or the initial temperature of water. Okay, so it is 25.3. So now we have to move the thermostat. In this way, by shifting the cover of the Dewar vessel in this way, but the mesh is remain in water. So now I have to open the double wall container and let the shots go into the Dewar vessel. Quickly, I have to close the Dewar vessel, put the thermostat, and shake the shots so they can deliver the heat quickly to the water. And after about 1 minute, in 1 minute, almost 1 minute, we read the new temperature of water. So the new temperature of water has raised to 28.3 degrees Celsius. So T final stops at 28.3 degrees Celsius. So T final is 28.3. First we turn off the heating apparatus, and then we remove the thermostat and we measure the new mass of the system, Dewar vessel, water, and shots. So the mass, the total mass is 553.5. 553.5 gram. So M double prime, which is the mass of Dewar vessel plus water plus shots, and M prime is the mass of Dewar vessel plus water. So by subtracting M prime from M double prime, we can find the mass of the shots, which is M1. So by a quick calculation, we can see that it is about 400 or yes, 40 gram or 40.46. Yes, so 507.9 minus 553.5. We have 45.6 gram, the mass of the shots. 45.6. M1, small m1, 45.6 is the mass of the shots. So what remains to do is to find C1, the heat capacity of glass, by doing the calculation. And the calculation, as I said before, is Q1, the heat delivered by the shots, equal Q2, the heat absorbed by Dewar vessel plus shots. So now we have to open the heating apparatus, put water again, a cold water again, and we have to repeat the experiment or repeat all the steps with the copper and in the third part using the lead shot. And as well we have to wait for 20 minutes. Start by measuring the Dewar vessel mass, empty Dewar vessel plus water, and then the Dewar vessel after 20 minutes we measure the mass of Dewar vessel plus water plus shot, and so we can conclude or we can find the mass of the shot alone for copper or for lead. And same, we have to use equation Q1 equal Q2 in order to find the heat capacity of copper and the heat capacity of lead. That's everything for this experiment. We will see that we will have three different heat capacity of the solids. The heat capacity of glass is different from the one of copper, different from the one of lead. And the heat capacity is a physical characteristic, so it does not depend from the mass of the shots or the shape of the shots that we put in water. The raise in temperature will be proportional to the mass of the shots that we are using. That's everything for this experiment, and see you later for a new experiment in the physics lab.